Okay. Before we get started, in case anyone was on the bird hike yesterday at the Bashkill, we had a great time, great bunch of people, great bunch of birders. But one of the ones that was so frustrating is there's a bird called a ruby-crowned kinglet. They're smaller than sparrows. They never stop moving. And we saw a bunch of them, but like they never stop moving. And they're small and they're in the bushes. And they're like, oh, it's a ruby-crowned kinglet. Oh, Nancy, it's coming, it's coming. And I was like, I've seen ruby crown kinglets, but I've never got a good picture. So there was a duck we saw, there's a bluebird. But then I did get one picture, well, like one picture. You could just barely see a little bit of the ruby crown. Not what I wanted, but like they were moving in the bushes so much that I'm happy I got that picture. At the Bashkill. Yeah, that's true. Yeah, yeah. So just in case anyone else was on the hike and was watching the recording and you had your binoculars and you didn't quite get to see it, ruby crown kinglet, and it's more impressive than that, but we'll take it for the day. Um, and just as always, thank you to Cultural Affairs. And Dorothy, if you wanted to say anything, you would be welcome. With Earth Day coming up and with the warmer weather coming up, the Bashkill was where we did a bird hike yesterday. And every weekend until mid-June, if you were to go sometime between 10 in the morning and 4 in the afternoon at the main boat launch where you would park, there are volunteers with spotting scopes who will say very nicely to you, hey, would you like to see bald eagles at a nest? And they'll focus in on the nest, or they'll focus in on whatever birds. And it's kind of fun because over the weeks you can see, oh, the eagles are bigger than they were the last time I was here. So, that's a neat thing in our area. The Orange County Audubon, as always, has hikes and events, etc. I'm doing a talk with Sullivan County Audubon this Thursday at the Mammocating Environmental Education Center on spring migrant birds. I'm actually doing the same talk here next Monday on spring migration birds. So feel free to come to me or come here next Monday, either or. But my point is, if you find this interesting, lots of people find this interesting with you. You've got people, you've got a crowd, and they're doing lots of cool things. And so if you wanted to look around, you might find outings that you enjoy and meet people who are of like mind. So there's a lot to enjoy there. Oh, and getting towards the end, we're approaching the end where we're going to talk about spring migratory birds next week. Then we're going to talk about human evolution. And I'd like to make that a little shorter in that I'd like to bring out all the skulls that we have, replicas of all of these hominids, and give you, time to kind of like explore it on your own. And then so, a little more hands-on than we usually do. The week after that, I'm not sure if Zooming works very well, because what I'd like to do is walk up these stairs. So the stairway right behind us, kind of made it like almost like a little museum exhibition where like each step is 8 million years, and we can kind of talk about the changes over time. And you're actually like, oh, okay, here we are in this period, and this is what's going on. Here, go up a little further. So there might be a short Zoom, but then it'll be kind of a walk. Through time, and I hope you'll enjoy that. And then the week after that, yeah, I'm sorry.
I was on this 2 years ago, and Walter just made it so fascinating. You absolutely have to come, and you have to bring your friends and relatives. We had all three staircases filled with people. I think we had at least 60 people. And you go at your own pace. I mean, not everybody walks as fast as others. It's just wonderful.
I personally, because I struggle to keep all the dates straight in my head, like when did the first reptiles appear, et cetera. And it's kind of fun to stand on this step and like, oh yeah, here's the mass extinction, but they started way down, like you can see it. You're like, oh, like it makes sense now in a way. So I get a kick out of it.
All of the illustrations, all of the steps are marked. He did the whole thing. So when you see this, you will be absolutely amazed at what put into.
Thank you. That was very kind. Thank you. And then the final week here before we are trying to put together a summer program. So kind of new. This is a lot of fun. Maybe continue it. So we'll get to you on that later. The last week, and this will be during finals week, we did this in the fall. It was a wonderful success. We'd like for me to shut up and like to turn it over to you because like you've gone on vacation and seen birds, or you have pictures that you've taken of birds, or you have questions. We were thinking of like inviting maybe members of some of these organizations, environmental. So if you had questions about the sanctuaries, you could, because a lot of you I know are members of these, you could actually ask some of the officers, make it kind of like a community participation event. So during finals week, those are the last couple events that we'll be doing. So I have like just more images and videos than we have time to tell, because it's just such a fascinating story. And so I'll zip through this as best I can. But if anyone sees videos that you say, ooh, like there's just so much more to see, this is my YouTube channel for free, Dr. Jan 41. So if you just type in DRJAHN 41 and space YouTube, you'll get all these videos if you want to watch the longer version. Okay, as we treat the diversity of life on Earth, we've hit group by group by group. All right, at some point we get to the mammals. That's today. So that's a mammal. That's a mammal. That's a mammal. We're mammals. My kids are in there. Okay. But the world went most of its history without mammals. Right. So that then raises the question, where did mammals come from? Because there was a time since the Carboniferous, there weren't mammals, but there were reptiles. All right. When I think of reptiles, I think, well, like we got snakes, we got lizards, we got turtles, we got crocodiles. Could like a crocodile evolve into a deer? Answer, no. Could like a snake evolve into a chipmunk? No. Could a turtle evolve into a skunk? No. So we have reptiles going back, 300 some million years ago. Where do mammals come from? And it's a fascinating story. And the problem is, here's the big problem, and I don't mean to be critical, but this is a problem. There are a lot of fossils that we really know well. So like Tyrannosaurus Rex. I mean, it's not that long ago with Barney, like there was a big purple Tyrannosaurus Rex that like sang to children. Kids know that one. Kids know Triceratops. But if we were to talk about some of these, there are a lot of these things most people have never heard of, but they're our relatives. So like, the dinosaurs, that's the other branch of the family tree. And a lot of we know that branch better than we know our own. So I'm going to have to start off, if it seems unreasonable that reptiles could evolve into mammals.
Decker, or one of what? I'm just.
I'm sorry, I'm just going to mute. If anyone has a question, feel free to put it in the chat. But otherwise, I'm just going to mute anyone. I'm going to tell a story with characters that you may not know. So when reptiles first appear, they have no holes in this area of the head. All right. There's a name for that, anapses. Now, you might say, who cares? But you do. You have a hole in your head. So if I were to run over the skull, which just happens to be here, look at that hole. You got a hole there. That hole allows jaw muscles to not end here, but to go through the hole and go up here. Bigger jaw muscles, more powerful bite. If you didn't have a hole there, like the first reptiles, you couldn't bite hard. You couldn't eat really well. All right. Now, by the mid-Carboniferous, here's a reptile. It's a reptile. It's dragging its belly on the ground. It's not that smart. It's got a small brain. It's cold-blooded. But look, it's got a hole. Not only does it have a hole, it has the synapsid hole, the hole that the mammals will have. So today, the only animals that have that hole are mammals. Like snakes, crocodiles, they have two holes, and that's different. They're called diapsids. And look at that, a canine. Different kinds of teeth, including a canine tooth. Like crocodiles, they just have sharp, pointy teeth. All right, they're all the same. All right, but here they're starting to be different kinds of teeth, including a canine. So this thing is a reptile. But if I were to like give it percentages, etc., I would say this is maybe 95% reptile with maybe like 5% of mammal thrown in. And these guys start to rule. They get to be like 9 feet long. Like the branch that will lead to the dinosaurs, they're not doing all that much just yet. All right, they come into play later. So these guys are huge. Or they're like these crocodile-like things. Some of them develop these big sails. Now, sails look weird, but that's telling me that temperature is important. They feel so strongly that they want to regulate their temperature. all right, that they're saying on a cool day, I want to warm up faster. On a warm day, I want the wind to blow. And with the sail, I'll cool down faster. Maintaining my temperature is important. Now, mammals feel that way too, but they do it with hormones. These animals wouldn't have had the hormones, but they're at least thinking, I have to maintain my temperature the same. All right, so we call these pelycosaurs, and they're the dominant land form for tens of millions of years. Now we're getting into the Permian period, and then from them, a new group evolves. All right, we call them therapsids, not that you have to remember that word. All right, and look at that canine. Like some people will refer to some of these as the saber-toothed reptiles. All right, their head's getting a little bit of a dome instead of being flat. That's kind of cool because mammals have a dome. And when I look at this, I'm struck by two things. I'm struck by primitive because look, they've got ribs here. All right, that's primitive. We mammals, we don't have ribs in the lumbar region. The brain is bigger than a reptile, smaller than a mammal. Different kinds of teeth, but they can't chew yet. All right, they're semi-sprawling, so they're not dragging their bellies on the ground anymore. They're partway erect. So here we're going. I'm thinking like 60% reptile, 40% mammal. All right, at this point. Then from them comes slightly more advanced. If you were to think, you might think that looks doggy. That's a reptile, but it's walking upright. Its tail is shorter. I could go through a whole bunch of things. Like reptiles, the way they mostly move, turtles would be a big exception, is they do this. They're moving side to side. So the arm and like reptiles, they don't have big, they're not built. They don't have big biceps because it's not the arms and the legs that are moving them. The arms and the legs just kind of grab onto a rock, and then it's the back, like ha, the back, and then they hold their arm and other, and they're like ha. So it's like the back muscles as they do that. That's the strong thing that are pushing them forward. That way they don't have like big arm and leg muscles. But these things, their back starts to be straighter. All right, they're not using their back as much like this, and now they're starting to use their arms and legs more. So these muscles are getting bigger. And so by this point, I'd say maybe we're looking at like 50%, mammal, 50% reptile. We get into, and there's all of these different guys. Some of these guys are 12 feet long and the biggest carnivores on earth. Like they rule. Once again, like all these kids, they know the big purple tyrannosaur, the biggest predator of its day, but no one knows the gorgonopsids, the biggest predators of their day, and they're related to us. All right, but in any case, then comes, even like at the very end of the Permian, this next group comes, we'll talk more about them in a second. The Permian is the worst time in Earth's history to be alive. 250 million years ago, 90% of life dies out. All right, a whole bunch of things, the largest volcanic eruptions in Earth's history, the continents were finishing coming together, just all of this stuff, just everything collapsed. And like if you were to, like in the ocean, if you were to go scuba diving in the age of dinosaurs, you would recognize most things. You'd say, oh, I kind of know you. You look a little different from the one I know. But if you were to go scuba diving in the Permian, you wouldn't recognize much. You'd say, this is just weird. Because that Paleozoic life, Paleozoic means old life, it just dies. And so then in the Mesozoic, that's when, we get the first turtles, we get the first mammals, we get the first dinosaurs, we get the first crocodiles, we get the first, all of these things, because the previous groups had died out. So these mammal ancestors, they were on top of everything, but then the world's mass extinction just hits them like a rock. There is a group that survives called the cynodonts, but they are now living in a world which more and more is going to be ruled by the reptiles. So the mammal-like reptiles, the synapsid reptiles, they were on top, but that is over. And so a lot of them will get smaller and smaller, these cynodonts. Now, I would love to make this a long talk about these guys and their skulls and their teeth, but that would mean we'd have to cut short the whales and the horses and the elephants and so choices. The point is, like, if I were to say, is this a mammal or is this a reptile? So if you let's just hypothetically, and forgive me because I teach here at OC, no offense to students or past students, I don't always assume that you were paying attention at the beginning. So if I were to ask you a question from the beginning, is that a mammal? Okay, good. See, they're easy to tell. How about this one? Mammal? Okay, see, they're easy to tell. It's hard to distinguish, to confuse a mammal and a reptile today. But if I said, here we are in the mid-Triassic, here's a fossil, I'm sure I can find pictures in a second. Here is a fossil of a cynodont. All right. And if I were to say, is that a mammal or a reptile? You would find yourself saying, all right, I need to look at the inside of the lower jaw for a groove that may only be a millimeter or two long. That's going to sway me one way or the other, whether it's a mammal or reptile. And this is true. When I say I'm thinking that this thing is a mammal or I'm thinking this is a reptile, there are other experts who are going to disagree with me. So the people who know the most about this fossil, some of them will say that's a mammal. Some of them say like, reptile. Could we throw out the word mammaliform, where like almost a mammal, not quite a mammal? So my point is, over 160 million years, things which are like all reptile with just like a hole here and a big tooth, they get to the point where it's hard to distinguish between them and mammals, that the experts would argue over this. Now, it took a long time. It took 160 million years to get to this point. Um, and it's a fascinating story. And unfortunately, most of us, we don't know the cynodonts, very well, et cetera. Now, the reason I find them so interesting, and for some of you, you already know that, like, so interesting to make a song about. We'll just hear 10 seconds of this. I swear. The thing that I find so fascinating is if I were to say what's primitive, all right, let me list those in red. What's advanced and mammal-like? Let me put that in purple. Like a lot of these are mixes. Like, ooh, here's the reptile and reptilian feature. Here's the mammalian feature. Here's the reptilian feature. Here's the mammalian feature. So you see mammal nests developing slowly. And if I say, what am I so proud of that I have and the reptiles don't? Like, I breathe better. I use my diaphragm, so my guts hang out, my diaphragm pushes down, but then my breathing is better. And I say, oh, wait, no, this reptile invented that. Look at that, it's missing the lumbar ribs. If I say, I'm warm-blooded, we say, well, if you look at the holes in the bones, given that endotherms have more holes for blood vessels than reptiles do, no, we think being warm-blooded started by about here, all right? I have hair. Yeah, but if you look, there was like fatter pads around the tip of the snout. We think that they at least had whiskers. All right. So a lot of the things that make me proud to be a mammal, it was actually the reptile ancestors of mammals that got a lot of those, or at least, started them off. So that's a fascinating story, but we have other places we'd like to go. Yes. Ooh, okay. All right. All right. We're going to have to go backwards because that's a great question. All right. But it's not going to make, all right. So, okay. So I'm going to try to make, I want to make this 20 minutes. We'll try to make it 90 seconds. If I were to say, let's talk about like the final days of, reptile versus mammals, let's talk about the mammalian lower jaw. And I scan the room for excitement. Yeah, I see one. I see one. That's so much more than I usually get. Okay. You're thinking, what? I mean, the mammalian lower jaw, it's one bone. It holds the teeth. It's got the jaw joint. Here's where the mandible hits the temporal bone for that TMJ joint. What could be happy about that? Well, see, if you look at a reptile, it's just like, ooh, there's a bone, there's a bone. There's not just one bone, there's a bunch of bones. So let's just say, all right, what did like fish bones look like back in the day? All right, look at all the bones. Now, the bone that we have is the blue one. All right, so you're going to watch the blue one. What's the jaw joint? Well, it's where the red bone touches the two yellow bones, the quadrate articular jaw joint. That's the quadrate bone in yellow touches the red bone when a reptile opens and closes its jaw. Now, you don't have that. You've got where your mandible in blue touches your temporal bone. You have a TMJ. So you've got a different jaw joint. So you ask the question, how did this jaw become a mammal jaw? And the answer is really, really slowly. That over time, the blue bone just starts to get a little bit bigger. The other bones, they just get a little bit smaller over time. All right, so notice the blue bone's getting more prominent, these other bones getting smaller. Notice the blue bone's getting bigger, more for jaw muscle attachment, stronger jaws. The later mammals, they will be chewing, so they're going to need longer jaws. But still, the red bone touching the yellow bone, that is still the jaw joint. Now, by the end, the pink bone's developing this weird hook. We'll come back to that. And on the inside of the lower jaw, this is the outside, this is the inside, there's like a bar of little bones, which is interesting because when you were a fetus, you had a bar of cartilage right there where that's happening. But still, the yellow and the red, that's the jaw joint. Then you get to the therapsids, and you know what? The upper and lower jaw touch here. So there's a yellow-red jaw joint. Ooh, but this is now touching the temporal bone. There are two jaw joints. The reptile joint that's on its way out, the mammal jaw joint that's on its way in. And then these get smaller and smaller, and at some point, we're left with just the blue bone, all right, which is all the lower jaw, holding all of the teeth, and that is making the jaw joint as the blue bone touches that. And we could argue, and I don't feel like arguing, does that happen at the base of the mammal tree, or did the first mammals, were they a couple steps before this, and that this happened separately in the lineage that would lead to the egg-laying mammals and the ones that would lead to live-bearing ones? The experts disagree, so I don't know what the answer is. But to me, the fascinating question is now, one of the things that makes mammals different from reptiles is in our middle ear, we have little bones that reptiles don't have. Reptiles have one inner ear bone, we have three. Your question is, where did the other two come from? The answer, the yellow and the red bones. So once these little bones were no longer needed as jaw joints, two of them just moved, all right? So two of them then become, so the stapes is the oldest one, but the mammals get two more and they just move in here. And if you were to look at a fetal skull, you would see one, here's a bone that we don't recognize as an adult. So it's kind of like a hook. That's the pink bone. And that supports your tympanum. So notice here's the jaw, there would have been the pink bone, and here would have been the yellow and the red bones in the jaw area. When a kangaroo is born, they are in the jaw, just like they would have been. And then they migrate to the ear because now the mammalian jaw joint is just this one, and they take on a new role hearing. So just like fascinating stories, like the lower jaw. No one thinks that the lower jaw would be interesting. It turns out it's a fascinating story in the evolution of the mammals. But we move on. So this, I think, might be funnier. At least my students pretend that they think so. In that I have an assignment for my students where here we're like sending hominids back in time and we're interviewing them as they talk about mammals. So mammals exist, real mammals, by the late Triassic. So dinosaurs beat them. The first dinosaurs appear in the mid-Triassic. So the world is now ruled by reptiles. Mammals come by, but they're actually, well, I'll get to that. So, the reptiles have beaten them to top parts in niches. And if we were to send mammals, so we were to send a reporter back to the Mesozoic, because if we were going to interview Mesozoic mammals, this is 2/3 of mammal history. Now, for some of you, you're thinking, wait, the Cenozoic era, the past 65 million years, that's the age of mammals. Here we are in the Mesozoic. This is before the age of mammals. 2/3 of mammal history occurs before the age of mammals. All right. So if you ask, well, that's a long time. All right, 130 million years. What did mammals do with 2/3 of their history? So we'll give you a preview. Here we go.
Of my search for the Haramayans. Yeah, they're small. They're from the Triassic, meaning they're early. I'm not sure, but they might be related to the multituberculates, which come later. That's about all I know about this group.
Now, I make my students sit through more of this. Okay. Doc, why do reptiles still exist? Okay, so a little aside, someone asked, why do reptiles still exist? Let me answer it. If someone were to ask, why are there chimpanzees still? My answer would be because even though this is an age where humans are doing so much, chimpanzees are out in jungles eating raw monkey. And just, I'm going to speak for myself. I'm not going to do that. All right. So chimpanzees, they can thrive because the world's a big place. They can do their thing in some areas where they're not threatened by me. And in the same way, like if you go to Brazil, being warm-blooded isn't that big a deal because it's hot most of the time. And being warm-blooded just means you spend extra calories. So there are parts of the world where there are advantages to being cold-blooded. All right. So reptiles have advantages in some scenarios. So I'm going to make this a really quick answer. So while mammals do a lot of things really well, they don't do everything. And in a lot of habitats, niches, reptiles have the advantage. So that's why reptiles are still here. Like the idea that a snake can chase mice down a burrow, right? No mammals are really good at that. So we got lots of rodents, but the fact that snakes can chase them in their burrows. So there's room for snakes. Good question. But then getting back to here, this just repeats itself, where we go looking for another group of mammals. And what are they doing? Not much. We have small rodent-sized things. We don't have many fossils over. We have lots of mammal fossils, but they're tiny. These are rodent-sized things. So we got like rodent-sized ribs and rodent-sized finger bones, and there's this. And well, let's not go after the gondwanatheres. Let's go after the trigonodontids. Let's go after these guys. And the story is the same. So if I were to sum up, what did mammals do with 2/3 of their history? The answer, not much. If I were to elaborate, there was one the size of a woodchuck, one a little bigger that even had a baby dinosaur in its gut. Some could swim a little better, all right, like being muskrat-like. Some could climb a little bit. That's about it. No, and not to be, I like mammals, so please don't think I'm being overly judgy. But they had a planet for 130 million years, and I just summed up what they did with it. All right. Not a lot. All right. So the world was truly ruled by the reptiles. Now, they diversified during this time. There were lots of little groups. Most of them will ultimately become extinct. Of these Mesozoic groups, there are 3 that are alive today. Okay. So let me just kind of introduce the 3, and then we'll get to like the end of the dinosaurs and the deaths, etc. And you know what? I'm going to open one more. I have so many videos. I'm like, oh, I don't think that one's the word. So one of the most primitive lineages has never been like overly common, but they give us a look at what the first mammals would have been like. So we have 2 egg-laying mammals, and one of them obviously was in the song. Fascinating. All right. So it's a mammal. It has hair. It's warm-blooded. It produces milk. It's a mammal. But it also reminds me of reptiles in a lot of ways. In that, while it has milk, it doesn't have nipples. Like milk glands or modified sweat glands. It just kind of sweats milk onto its abdomen, and the young lick the milk off of tufts of hair. It has a cloaca, and that's actually what the name monotreme means, one hole. We, higher mammals, we say, you know what, we're going to kind of separate the urinary, the reproductive, and the digestive system exits. Whereas if you look underneath a fish or a snake or something, no, they just have one hole for all of them. So the urethra, the anus, the vagina will all empty into this one hole called the cloaca. The platypus has that. The platypus has bones in its shoulder that no other mammals have, other than the other egg-laying mammal, the echidna. But reptiles do. All right. The mammals, and we could go into the kidneys, we go into a bunch of things. This is a mammal, but it lacks features that other mammals have, and it possesses features that reptiles have. So it shows us that mammalness evolved in stages. Not only did it take reptiles a long time to be mammals, the first mammals are not anything that you would recognize. It took like another 130 million years before we started getting into the groups which we see today. And the platypus shows us, like here's a partway station where this animal had enough to be a mammal, but not enough to be a live-bearing mammal. Now, there are then, and it was right here, maybe I'll just call it again. Yeah. Here's another song. actually forget how it goes. Okay, that's weird. I forget how some of my phones go. So mammals, mammals first appear by the end of the Triassic. By the time we're in the Jurassic, one of the lineages says, hey, you know what would be neat? Live birth. I think evolving live birth, quite the big deal. All right, I think this is a big deal. I'm really impressed by it. But in fairness, mammals did it once. That's why I'm impressed with it. But sharks did it. There are sharks that give live birth. All right, and then there are sharks who give live birth with a placenta and without. So maybe it happened more than once. But snakes, lots of snakes give live birth. Rattlesnakes do. Copperheads do. All right, so in our area, about half the snakes lay eggs, half the snakes give live birth. In snakes, it probably evolved multiple times. In lizards, it evolved a whole bunch of times. Like in the skinks, some lay eggs, some give live birth. In this group, some lay. So live birth's a big deal. All right, but it's a bigger deal for us mammals because we only did it once. A lot of the reptiles, they did it a bunch of times. So apparently not as hard as we make it out to be. But in any case, by the Jurassic, we have therian mammals, which give live birth. Now, that's a good trait to look at, but their brains are bigger, all right, more of a cerebrum. They've got now a modified shoulder, all right, so there's a part above the spine, and I'd be happy to go into this. The way that you determine a male is there is a gene on the Y chromosome called the SRY gene that says, I'm going to start testis development, you're going to be male. If you ask me, I've taught it, I've made videos on it, I still don't understand it. If you ask, how do the egg-laying mammals determine their gender? It's like if you have like X1, X2, Y1, Y2, this, and there's like a whole chain of these, and they all attach to each other. Like it's crazy. It's really hard to explain how you make male and female egg-laying mammals. But here in the live-bearing ones, it says, no, we have two different kinds of chromosomes. One has a gene. If you get the Y that has the SRY gene, you're male. If you would get the X that doesn't have the SRY gene, you're female. So there's all of these things. We could talk about the shoulder. This part of the shoulder is brand new. But now these live birth mammals, they are new. And once we have these live birth mammals, these are, some of these we'll see it in just a few minutes as like the marsupials, which are alive today. Then there's another group that says, hey, let's give live birth, but in a slightly more advanced state. Let's have like marsupials do have a placenta, but placental mammals have a different kind of placenta. And so like a kangaroo, when it's born, is the size of a bee and needs the complete development in its pouch. Whereas a lot of placentals, like a baby deer, is walking by the end of the day. Placental mammals are just born in an advanced state. So by the end of the Cretaceous, even though mammals aren't really impressive, and they're the size of rodents and pretty generalized, nevertheless, there's a couple different groups. There's the egg-laying kind, and among the live birth kind, there's the therians, which would be like the ancestors of the marsupials, and there's the eutherians. And then something unexpected happens. Let me play a little of this song once again.
Dinosaur. For the day. Only mammals and scamper away. On that Cretaceous day when the sky turned fire, it was a challenge just to stay alive. But it wasn't the dinosaurs, those continued dinosaurs, but the mammals that survived.
Okay, so there's more. But dinosaurs kept us down for 130 million years. And then suddenly they were gone. Two reasons. One, the second largest volcanic eruptions in history were going on in India. And I don't mean to be critical of continents, like, so if you're fond of India, like, but what was India thinking? Like, it was part of Africa for the longest time. And then decided, no, I want to move and I'd like to be part of Asia. And it moves faster than like subcontinents ever do. And just the volcanic activity created like the second largest volcanic eruptions that we know of. Right, so the Permian extinction, worst mass extinction, biggest volcanic eruptions we know of. At the end of the Cretaceous, second biggest volcanic eruptions, and the second biggest mass extinction in the past 500 million years. But then at the same time, a big rock falls out of the sky and hits where Mexico and Guatemala meet. So the mammals, they were not thriving, all right? But all of a sudden now, nothing that's bigger than, say, a woodchuck survives the day, all right? So there was a horrible day where just a big rock falls out of the sky, kicks all of this stuff up into the atmosphere, and then it comes down. And as it comes down, you're like, oh, here's a meteor, but you wouldn't love millions of them, because as they heat up coming in, that would just heat up the air until it's about the heat of like a pizza oven, not a regular, like a pizza oven, they're hotter. And just everything that was big died. Nothing big survived the end of the Cretaceous all over the world. But these little mammals, many of which were probably underground when the thing hit, they do. And now the world is a different place. So just as the mammals, the mammals were kept down by the reptiles are now kept down by us. I mean, reptiles can do great things. All right, I mean, there were lizards that were 50-foot long swimming in the ocean. They could do that again. All right, but we mammals won't let them because we have whales and, you know, killer whales, and we've got lions and tigers. So the big dominant reptiles, they kept the mammals down, and now the big dominant mammals seem to be doing the same for them. So let's look at the mammals that are alive today and how they came about. So now we're 65 million years ago, and we'll trace different lineages and talk about the modern diversity. Yes.
I don't know a lot about evolution, so maybe this is a weird question, but you said the dinosaurs kept, the big animals kept the little animals down, the reptiles. Was it, maybe they didn't need to evolve, like, that they have been just so well adapted to where they live that they.
So you have rodent-like mammals, which are good at what they do. But we know, like, let's just take whales. We know that mammals could get bigger and live in the ocean. We know that mammals could get bigger and eat plants. They could be deer or cows or giraffes or elephants. We know that these little mammals, they have that potential in them. But at the time, the world was full of big reptiles that ate plants and big reptiles in the ocean. So that was not an empty niche. Like, so if you say, ooh, you know what? I think I'd like to, I don't know, design a car. Now, if I could go back in history like 200 years, I could really be onto something because there were no cars. There's a window there. I could be wildly successful inventing something new. But if I try to compete with the people who are already inventing cars, I'm probably not going to do very well in trying to invent a car from scratch against their established niche. So the same thing here. If you've already got really successful animals that are big terrestrial carnivores, these little guys, they really don't have time, because if they try, ooh, let me try to get bigger and eat plants, here comes a big dinosaur that, you know, just eats them. But once those dinosaurs are gone, that changes everything. Good question. So the marsupials. Well, we have marsupials, all right? So we have the opossum, all right? So these give live birth, but their infants are tiny, 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 insect-sized, and they crawl into the mother's pouch, latch onto a nipple there, and then they complete their development. So this is like these the other marsupials. Marsupials were once pretty common. All right, North America had a bunch. South America was full of marsupials. But as I'll get into, something happened 4 million years ago. South America and Central America touched. And who went down south? All these carnivores that, you know, the marsupials of South America, and there were a lot. There were some that were bear-sized. There were some that were saber-toothed cat-sized. There were big herbivores. They died. And now there's only a handful left. So South America has rodents. They look like rodents, but they're actually marsupials. And they have opossums. And one of the opossums came north. So the opossum is a recent, like 4 to 6 million years ago, immigrant from South America to North America and has done rather well. Most of South America's marsupials have died. So the only continent where marsupials are really doing well today is Australia, because that stayed so isolated that you can still find all of those. So if we have egg-laying mammals and marsupials, which outside of Australia aren't really all that successful, then it's the placental mammals that deserve the remainder of our time. What's the starting point for placental mammals? Well, if you want, like what did the first placental mammals look like? Here's the best thing you can do, a shrew. Now, it's rodent size, but it's not a rodent, so it's an insectivore. And it has so many traits that remind me of a reptile. Its cerebrum is smooth. The testes do not descend into a scrotum in males. That's a primitive feature. A lot of animals have that, like elephants too. Elephants don't have their testes descend because elephants are an early branch of the mammal family tree. They still have a cloaca. They still have one hole for the urinary, reproductive, and digestive tracts instead of separating it into multiple ones. So this is how, like, a good idea of this is, how placental mammals got their start. Okay. From the early placental mammals, 65 million years ago, the world has lost 60% of its life. And mammals realize there are holes in the environment. Pterosaurs are gone. There are no more flying reptiles. The big group of birds are gone. So today we have birds. But in the Mesozoic, there was a different group of birds, the opposite birds. They were the ones that ruled. They die with the dinosaurs, right? So birds will recover and will give us things like songbirds and crows and all. But that comes later. There are no songbirds when the dinosaurs died. No dinosaur ever saw a sparrow or a warbler or a crow. They come much, much later. So mammals realize there's all these flying bugs. No more flying reptiles could eat them. The major group of birds is now gone. So one group of mammals say, we could do this. And they become the bats, the third group of vertebrates to fly. All right. And if you want to say, well, how did they do that? Well, if you watch bat embryos developing, you can see that bats start off with normal fingers, and then the fingers just get really long. And then the skin between them is now something that can give you a little bit of lift if you're really small and you have a light skeleton. Now, bats evolve over time because that echolocation, where you make like really high-pitched noises through your really weird nose, bats can have weird noses, bounce off of bugs, and you pick them up with your really big ears. The first bats didn't do that. The first bats caught fish. The first bats, are like the flying foxes today, which can have like 4-foot wingspans. Some of them just eat fruit. Some of them eat fish, some of them pollinate plants. It was only later that bats said, ooh, we can hunt for insects. So bats were certainly not fully formed when the age of mammals starts. They develop that. And just mentioning it, we have bats in a diversity here, but we also have endangered bats. And so if you were to look at who's on the endangered species list, a lot of them are bats. Now, some of them are native to really small areas like Hawaii or Guam or the Marianas Islands, etc. But then a lot of them here, they don't have the largest of ranges, and we consider them endangered. So like the Indiana bat is considered endangered in the state of New York. All right, so as we try to protect endangered species, bats are among them in our area. Rodents. So rodents are the most successful group of placental mammal, like about half. Maybe we could argue whether it's half or not quite half. About half of all placental mammals are rodents. So like if I were to say name a mammal, you'd say cat, dog, elephant, person. Those are bad examples. Like they're just not typical mammals. Mouse, vole, those are typical mammals. That half of all mammals are rodents. What makes a rodent are these big incisor teeth. Now, rodents have changed over time. So this is a beaver skull. Beavers are pretty big. This is the giant beaver, which lived here in North America. Right. So New York had giant beavers, right, which could be 9 feet long. And they were certainly here recently, maybe even when early Native Americans were spreading throughout the globe. What makes a rodent is the front teeth. All right. Not only are they big, but they continue to grow. Like mine don't. If you were to come back next year, see these incisors, they'd be the same length. All right. And I'm getting old, so like maybe someday I won't have these, but like they won't get longer. Okay. But if I was a rodent, that would be a problem because if you're going to eat rough stuff, seeds, like chew on wood, and like eat fresh, that would wear your teeth down more and more and more until you're out. So if you just have teeth that continue to grow and grow, that lets you eat things that a lot of animals can't eat. It's just too rough and fibrous. So that's the advantage of being a rodent. You can just go after all of this fibrous material. But you have to watch out. Like if you have a pet rodent, all right, or like if you're a park ranger and there's someone brings you a woodchuck, sometimes the issue you have is you look at the tooth and you're like, oh, look, this incisor kept growing. It's actually curved around and it's putting pressure on the animal's neck. One of the things you have to do with rodents is sometimes you have to cut the incisor, all right, because, it didn't, it just kept growing through that. But that's what makes rodents. And rodents have spread. Rabbits they're rodents, but really, we could argue that. Like they're related to rodent, but like they are so distantly related that some people like to put Lagomorpha in a completely different group. So just saying, like we call them rodents, but there's rodents and there's rodents. It's a, 50, 60 million years is a long time to change. So there are some deep divisions in the family tree. All right. A lot of them are small and kind of the ones we kind of know. Do I talk about it here? I should. I don't. Oh, okay, yeah, because it's the North American one. I'm sorry. Is it here? But if you go to South America, there's like weird rodents. And then by that, like porcupines are weird rodents. They're originally South American. So once again, when the Americas touched and North America started getting all of this influx of these weird South American things, porcupines came to North America. They were not originally there. If you go to South America, you'll still see agoutis and the like. But capybaras, or carpinchos in Spanish, they are pig-sized, and they are the largest rodents alive today. But they had cousins which were cow-sized, or at least the size of small cows. Now, I'm not sure if anyone's doing this, but maybe you're making this mental leap and you're like, oh, didn't you say a couple of weeks ago with the reptile evolution that if you were to go to the Amazon and Brazil, in the tens of millions of years ago, that you could find crocodiles which were like 40 feet long and anacondas which were 50 feet long? I wonder what they were eating. Rodents which were cow-sized. That's your answer. All right. So one of the reasons you had such big crocodiles and snakes back in the day is because you had rodents which were really big in the day. Okay. Now, I'm not sure if anyone came here to talk about rodents, but they do make up half of placental mammals. So, certainly worth the shout out. And today, all right, we have lots of them, but a lot of them are nocturnal, as were most mammals. So like during the age of dinosaurs, this is probably how mammals lived, mostly nocturnal. Lots of them in burrows. So when we get to primates, and that'll probably when we talk about humans, like primates make a big deal about vision and color vision. For most mammals, it's smell. All right, vision doesn't help you. All right, if you're going around at night, it's smell that really helps you. So just if you want to understand what mammals are, we have to just we're really different and a specialized group of mammals. Like these nocturnal rodents, they're much much closer to that. Here's a vole. You see it has a little slash in its thing. This was at the Liberty Loop. Probably either a harrier hawk or a short-eared owl tried to get it and missed. But if you like going to the Liberty Loop and looking for short-eared owls in the winter or harrier hawks or whatever, this is what they're eating. So once again, I'm not asking for voles to be your favorite animals, but if you like looking at predator birds, they're eating something. All right. So, these are important parts of food chains. Obviously, rodents can get bigger. In our area, we have woodchucks. We have porcupines, which specialize on eating the inner bark of trees, which is where the sugars are, and their quills have been stiffened. A lot of us confuse these for beavers, and then we notice, oh, look at the tail. Like that's a long, skinny rodent tail. It's not a flat beaver tail. So this is a muskrat, a little smaller than beavers. Beavers are huge. All right, so beavers are the largest rodents in North America. Although once again, they had 9-foot relatives, so they're not as big as they used to be. North America no longer has primates. North America used to have primitive primates, all right, but they no longer do. But if you look at squirrels, like in all honesty, they're kind of impressive how they can leap from tree to tree and balance, etc. So squirrels are taking the niche that primates used to have. You go to South America, they've got little monkeys, living up in the trees. We've got squirrels kind of doing a lot of the same thing. There are different kinds of squirrels. We have red squirrels in our area, which prey a little bit more on the nests of birds. We have chipmunks, which live a little bit more on the ground. All right, so we have a lot of rodents, and there are things that we could say about those. But let's now go into like some more of the mammal groups. And I'd like to talk about South America, just because that gets a couple groups out of the way. The continents have been moving forever, all right? And when the dinosaurs disappeared, the planet kind of looked like this. South America and Africa were separate, but not by too much, and North America did not yet touch us. Look at India. What the heck is it doing? It's all the way down here, like it's going to go up there, all right? So South America is an island for the longest time. It touches nobody. And a lot of the mammal groups that evolved in South America are then unique. In other words, they had like things that look like horses and camels that no one else had. They were not horses and camels, just another primitive lineage. They had these big marsupial predators. And then they still have some of the big birds. There were still like 6 and 9 foot tall birds running around eating everything in South America. So you have got these huge armadillos that weigh as much as a car. You've got these giant sloths, just South America has all these weird mammals. But 4 million years ago, this touches. All right, Central America joins South America and North America. And now all of a sudden, you have all of these things going south. So a lot of the marsupials die. So today, these are marsupials in South America. A lot of them look, kind of like rodents. They're still marsupials. But that's about it. The big marsupials are gone, although the opossum did come to North America. Porcupines came to North America. Giant sloths. All right, so we say sloth. I think the British say sloth, and I'm always trying to figure out what the best. So either pronunciation is fine. So today we have one. They're like these slow things that live in trees. They move so slowly, their fur can actually be greenish because moss can actually grow in their fur. All right, so that they're just slow moving. But when back in the day, there were elephant-sized versions of these. Interesting story. One of them is named after Thomas Jefferson. Our founding fathers were not just interested in like constitutional democracy. A lot of them were like, look at all these bones being found out of the ground. Like George Washington went to see a mastodon skeleton in Newburgh, or at least some of the bones. And Jefferson described a fossil sloth, and it's named after him. The species name is Jefferson. So these were exciting things. So from South America, we got giant armadillos before they would become extinct. We got giant, I said armadillos, sloths, etc. But today, if you say, how is your life different in North America because we touch South America? All right, well, we got opossums, we got porcupines. Florida and Texas have armadillos. All right, you go to Costa Rica, you can see some monkeys. That's about it. But if you were to ask the flip question, how was South America affected by touching North America? Oh, devastating. Because if you were to say, what's a mammal in South America today? The majority of them came from North America really recently and pushed the South American ones to extinct. So deer, they were North American, they went south. Camels, they were North American. You say camels are not North American. Yeah, camels got their start here, then went to Asia, and then went to South America to give us llamas and guanacos and vicuñas. So llamas came from North America, went south. That looks like a giraffe, but it's not. That's a camel that lived in the plains of North America. Pigs started here and then went South America to give us the different kinds of peccary there. Here's a tapir, or I think this is the Malaysian one, but South America has tapirs as well. But they came from North America. That's a rhino relative. All right, so there's South America got elephants. All right, so elephants were much more diverse than they are today. Some of them went down to South America. And then South America got the carnivores. Like today, there are cats in South America, jaguars, pumas, ocelots. They are North American. South America has dogs. They have foxes. They have the maned wolf. They have the ground dog. They are North American. They had bears, including one of the bears probably was eating the elephants. It was 2,000 pounds, we estimate, bigger than the biggest polar bear. All right. So if you ask, like, what was the biggest predatory mammal of all time? Probably in Argentina, this huge bear that was eating the elephants here. But the point is, South America was just devastated. All right. They had a native fauna. They didn't just have like an invasive species here and there. They got dogs and cats and skunks and raccoons and otters and deer and rhinos and elephants and just group after group after group. And it just completely changed the wildlife of South America. So that's part of the mammal story. But if we were to just keep on going into different groups of mammals, let's talk about elephants. So elephants have
Africa was largely isolated from other continents.
So just like camels and other things are North American, elephants are African. All right, they started in Africa, and for a long time, Africa was the only place that they lived. And they belong to a group called Afrotheria of African-only animals. Elephant shrews are among those. All right, but then so too were the first dugongs and manatees. They got their start there. So mammals said, look, the reptiles have vacated the oceans. There are no more reptiles in the oceans. So mammals said, ooh, we could be aquatic. And so some of them experimented with that. So like the ancestors of manatees, but then there were some groups that died out, like demostylians were like these hippo-like animals, which would swim and live at the bottom of the ocean. And then from this group, we get the elephants. Now, what makes an elephant? Well, one of the things that makes the elephant is the teeth. They lost most of them. All right. So they used to have a lot of teeth, like you and me, same kinds of numbers. But then they decided, no, let's lose most of them. Let's keep some that make them really big and make them tusks. All right. So a tusk is just a big tooth. Ivory. Ooh, this is made of ivory. Okay. This is ivory. Enamel. And ivory is just enamel. So an elephant tusk is just a big tooth. All right. So tooth stuff or a tusk stuff, ivory, is exactly what you have here. Just a big tooth has a lot more of it. And as these got bigger, one of the things I don't, just to really quick on teeth, all my molars are in place right now. My premolars and molars are all there. But elephant said, let's make our molars and premolars huge, so huge that the mouth can only fit 2 of them at a time. So as an elephant goes through its life, it doesn't have all of its premolars and molars at one time like I do. Instead, it'll just have 2, and then it chews grass, the teeth get worn down. So then it'll throw a premolar off. The second premolar moves up, the first molar moves down, and now it has 2, and it chews and chews and chews until the second premolar gets small. So then that drops out, then the molar moves up, another molar moves in, and eventually it runs out of teeth, and it's down to gums. So just like elderly individuals might say, like I'm losing my teeth. Old kangaroos, old elephants also run out of teeth, but their teeth are different in that sense. There are so many fascinating stories. So this is the quick view of all of them. Elephants, all right, there are no elephants in the Mesozoic era, but by the end of the Paleocene, this is the first epoch, we think that we have primitive elephants. They're pig-sized, all right? They don't have big tusks yet, but we're getting there. And if we could count they only live in Africa. And then from there, we get ones which are a little bigger teeth called Paleomastodon. From there, we get mastodons. Mastodons first appear, but they're successful and they spread all throughout the planet. So now these elephants are leaving Africa, going to Europe, Asia, and eventually then they'll get to North America as well. Now, the early people who study these things, they said mammoth, mastodon, it's all the same thing until Cuvier, the quote, father of comparative vertebrate anatomy, really big deal. I teach comparative vertebrate anatomy. Cuvier's a big guy. He notices, oh, this is not a mammoth. All right. And he says, because mammoths have a different kind of teeth for eating grass. And we now know that's significant because grass wasn't big on the planet yet. But as the world is approaching ice ages, the planet gets cooler and drier, grass is spread. So grass-eating elephants become the thing. But back in the early age of mammals, it was forest and leaves. So that's a leaf-eating elephant, not a grass-eating elephant. And you can tell by the teeth, that's for eating leaves, not grass. And it's so significant that Cuvier says, I'm going to name the elephant after those teeth. Those teeth reminds me of women's breasts. So I'm going to name the mastodon breast tooth. Masta referring to breast, Tooth, don, you go to the orthodontist, mass referring to breast, don referring to tooth. So the name mastodon comes from breast tooth because Cuvier said that's not a mammoth. Look at the teeth. That's a different kind of elephant, right? And so these spread all throughout the world, and obviously Orange County is a hotbed for mastodons. But then Africa has given us even more different groups. So there's elephants which didn't have tusks in their upper jaws. They only have tusks in their lower jaws, probably to rip the inner bark off of trees. These things get to be much bigger than modern elephants. Then you could get all of these gomphotheres, which have tusks in their upper and lower jaws. Some of these will make it down to South America. Then you get the mammoths. By this point, the world is getting colder and drier. And so these, like the elephants alive today, are very good at eating grass. All right. There are different kinds of mammoths. Some adapt to the ice age and are woolly. All right. And then there are so many elephant stories. Some actually end up being on islands and getting really small, like the size of cows. Now, in 2 weeks, we can talk about humans. There were a group of humans that stood 3 foot tall as adults, right, living on the island of Flores, where they had elephants the size of cows. All right. And so a lot of things got smaller on the island of Flores, right? But those are elephants. Yes. No, they were hairy, but not woolly. So if you were to look in the Paleocene and you were to say, what mammals do we see? Well, they're condylarths. About 70% of the fossil mammals you'll find in some place are condylarths. All right. What are condylarths? They're just generalized mammals. They are extinct today. But they gave us the hooked mammals of today. So in the Paleocene, we don't have deer or cows or sheep or horses, but we do have these condylarths, which are their ancestors. They form lots of groups. Now, they hadn't committed to eating plants yet. So some of the early groups are actually meat eaters, and some of them had 3 foot long skulls. Imagine a 3 foot long skull on a predator, all right? That's a big predator. It was rhino size. Now, maybe it ate more carrion than being a hunter, but still, these are cow relatives, and they're close to the record of the largest predatory mammals of all time. A number of them decided, hey, we can walk differently. We can walk on the tips of our toes and make some of our toenails really big and look like hooves. And these are the ones, the cloven hoof. And a cloven hoof, it's not a cloven hoof, it's just 2 separate toes. All right, so nothing special about a hoof, just 2 separate hooves. Some of them become pigs. All right, so we get pigs, and pigs are starting to separate their stomachs. Then hippos are related to pigs. They're a little bit better at eating plants. And then we get ones which separate their stomachs even more into chambers and are called ruminants. What are they eating? Look, they're not even putting their heads down. What the heck are they chewing? Well, what they do is if you're going to live on grass is not very nutritious. What happens is you eat it, you swallow it, you chew it. But there are so few nutrients there, and you want to get every single one, you voluntarily regurgitate it from your stomach back into your mouth, and now you chew it some more a second time. That's what ruminating is. You swallow it a second time, and now you've ripped it to shreds so completely that you're going to get all of the food out of this nutrient-poor, grassy stuff. But there's a lot of grass on Earth, especially now that it's becoming cooler and grasslands are spreading. So these ruminants, they give us all of these different groups, and they spread throughout the world. Now, just once again, camels. North America gives rise to camels. There are ones which have giraffe-like necks. Some go down to South America and become the llamas. Giraffes. All the early giraffes had short necks. Some were as big as elephants. Don't get me wrong. But they didn't have the long necks yet. Some of them had all of these big horns, as big as moose horns. So these were quite diverse. And then we get just all of these hoofed mammals. We get deer, but some of them were huge. All right. So quote, the Irish elk, which these weren't Irish nor were they elk, but we can call them Irish elk. These antlers could be 6 foot long each one. All right. So the deer are doing great. So we could go through that for all of these even-toed forms. I'm going to skip one, answer your question, and then get back to the odd-toed. Yes. Yep, that's exactly. Yep. There you go. Yeah, and that is another way for that would be called to ruminate, and they are called the ruminants that do that. So I'm going to skip a group and get back to the even toed. So cows, sheep, giraffes, they all have an even number of toes, right? But then some of the descendants of the condylarths have an odd number of toes. So they are called the perissodactyls. Some of them become rhinos. All right. Now you say, oh, I know rhinos. But rhinos, they were quite varied. Some of them got to be, yes, 20 feet tall and are the largest mammals of all time on land, not as big as whales. So that's a rhino. Doesn't have horns. Right. These were called the Indricotheres. They lived in Asia. All right. But rhinos were quite varied. There are other groups. Horses in a separate group. Sorry, where did I put my horses? Okay, yeah, here we are. Here we're in horses. And all right, so I'm going to do something. I hope nobody takes this the wrong way, please. I mean, no offense. The first horses are cat-sized and have multiple toes. But then what they do is they're living in a wet forested world. And in a wet forested world, sometimes you have to escape a predator and jump this way, in which case I need these toes. Sometimes you have to jump this way, in which case I need these toes. So lateral toes are good. But as the world dries up and more grass, now this is not helping me as much. I want to run fast in this direction. All right. And so then what happens is the middle finger gets bigger and bigger and bigger. And then these lateral toes get smaller and smaller. So essentially, this is what a horse is. A horse is running, once again, no offense. All right. Horse is running on its middle fingers, and the nail is the hoof. And we can see that happening. And this would be a great story, but I'm trying to tell.
Haven't always existed.
I'm trying to tell all the stories at once. But over, 50 some million years, you could watch things from being cat-sized to getting bigger and bigger. You could watch their skulls changing as they gradually stop eating leaves and get better and better at eating grass. You can watch them as their body size get better. They get better at running. You could watch their toes slowly decrease. But most horses have had more than one toe. So the one-toed horses, they are really recent. So there are three-toed horses. Now, a lot of these three-toed horses, the side toes were short, all right, but they were still there. But even when deer, all right, you can see there's the two main toes, but then you can see there are the smaller toes. All right, dogs, you have a dew claw of the toe that doesn't touch the ground. There have been horses which have had lateral toes. Texas had one in the circus. I'm going to tell you this is a story I heard, so it must be true. But the story that I heard was Julius Caesar had in his stable a horse with multiple toes, and a soothsayer saw that and said, someday you will rule the world. I don't know if it's true, but it would be weird if human history was changed because someone had a mutant horse in their stables. All right, so the horses, that's a story. I skipped one, all right, because on the even-toed group in Asia, there was some that were living along a seaway that no longer exists. There used to be this Tethys seaway separating Europe and Africa, which were not connected, and separating India, which had not joined Asia mainland yet. All right, so they hung around in the seaway, and then they said, oh, what would be cool? Let's go swimming. So animals that look like this, you come back a little bit later, and they look like, oh, we're still in Pachycetus? Sorry. Okay. Some of them look like this. Ambulocetus, whose name means walking whale, looks like this. All right. And then you have these forms. They're four-legged, and they can walk on land, but they are getting better at swimming. And then we can just watch them over time, where the nostrils, which used to be at the tip of the skull, just start moving up and up and up and up until it becomes a blowhole. Their legs get better and better at swimming. All right. Until very often, a lot of them just have these tiny little legs left, whether it be these durodontid whales or Basilosaurus, which was 60 feet long, having just 6-inch little hind legs there. We know from whaling days that if you look in whale blubber, you can still sometimes find a cartilage femur, a thigh bone, or tibius and fibulus. The first whales had legs. Modern legs still have legs, at least some of them, in their body wall. I believe the last group, just to go through very quickly, are the carnivores. So for the longest time, there were no carnivorous mammals. It was the reptiles that did that. The marsupials gave us some big carnivores. South America had some. But then even in Australia, there was the Tasmanian wolf. But humans get there, and the Tasmanian wolf, last ones were seen a century ago. The relatives of cows gave us those Mesonychians, so that they were primitive carnivorous mammals. There was a group called the creodonts, which probably weren't all that smart, but they were doing great for a long time until they died out. So when we think of carnivores, we're thinking of like cats, dogs, bears. They're recent on the scene. Not only did reptiles corner the market on carnivorous forms, when mammals became carnivores, there were other groups of mammals other than the ones we have today. Now, today we have bears and dogs, but there were, quote, bear dogs and wolf bears in the past as well. So mammals have, diversified quite a big deal. And then we could, obviously follow these groups alive today as they produce the mammals that we have. If we were to look in our area, obviously bears do exist
Black
here.
bears reach.
Now, South America still has a short-faced bear. That's a different family of bears. And some of them got to be really big. And one of them was that huge Arctotherium, which once again was apparently eating elephants and was the largest predatory mammal of all kinds. But we do have other carnivores in our area on the dog-bear half, like raccoons. We have red foxes. We have gray foxes. These are the most primitive dogs. If you look at the dog family tree and you see who's the first branch, it's the gray foxes. All right. Coyotes are closely related to wolves and dogs, so much that we put them in the same genus. So this is Canis. Foxes are not Canis. So coyotes are. And then wolves are actually Canis lupus, and that dogs are a subspecies of those. There are plenty of other kinds of carnivorous mammals. We have skunks. We have otters, and in Brazil, there's one that can reach 5 feet long. All right, otters have other relatives which are a little smaller, like mustelids. And something that was missing from Orange County for a long time were fishers. All right, but fishers are back. I've seen them. So here's a fisher at the Liberty Loop. We have trail camera video of them at in Goshen. So this is bigger than a mink, but smaller than an otter, one of those mustelids. And we have bobcats in our area as well. So here's a bobcat in the Bashakil. We have trail camera video of bobcats in Goshen as well. So the carnivores, they split to be a dog half and a cat half. Now, I think I've done a decent job of introducing some of the mammal groups, but I skipped one. I skipped the primates. But that would work in really well with talking about human evolution, to start with the first primates, then get through monkeys, apes, and hominids 2 weeks from now. So this was kind of starting with reptiles 300 million years ago. And we not only then followed how they slowly became mammals, all right, but then how there was this 120 million year hiatus where reptiles ruled and mammals didn't accomplish much. And then how in the last 65 million years, mammals have really come into their own, and they became flyers and the bats. They became whales, the largest mammals on Earth, but they became big carnivores, big herbivores, and they occupied all of the niches that those big reptiles had left vacant. Okay. So if anyone has any questions, feel free to stay. Thank you so very much for coming. Next week, we'll go through spring bird migrations and human evolution the week after that. Thank you so very much.
I get the impression that most trail cameras, you got to subscribe to some sort of, can you just download off a chip or
Oh,
something?
yeah. That's all these are.
Yeah, you don't hook up to the internet.
I do not know. Yeah, so I go, actually, here, let me just stop recording, because otherwise I'll. Yeah, so I